Okay, so we are, that's it. We're starting here. This is number 2 in that package. Number 2 in the 2014 SOL. Okay, operations with imaginary numbers. Okay, remember, imaginary numbers we get by taking the square root of -1 and we're calling that I. And the standard form of a complex number then is A plus BI. So how is it that we add or subtract these? Do you remember? Yeah, I mean, you could call it like the like terms. I mean, really, because I is not a variable. It's more, keep the i's separate from the real. So A plus BI, the A is all real. The BI is all imaginary. So you want to add the real parts and add the imaginary parts. If you want to think of them like terms, that's okay too. So let's say I was going to do that. And then, I mean, first thing I would have to do in this problem is just understand that this negative in front of parentheses means it's got to be distributed. And so I would personally take a step and distribute that negative. -6 minus I plus 5I minus 11 minus 13I. Okay, now I'm going to combine the real parts. -6 minus 11 is -17. And then we've got -I plus 5I minus 13I. How many i's is that? Right, that would be minus 9i. -1 plus 5 is 4. 4 minus 13 is -9. So the answer is that. Okay. However, understand that you can do this in the calculator. The calculator has the I character in it. Right? Where is it? It's on the decimal point. So if you go down, clear, look above the decimal point to the left, it says I, so I would have to do second decimal point. There's your I character. So you can enter anything, you know, any imaginary number, you can enter it in the calculator and do operations with that. Now, if you look in the mode key right there, which is just to the right of the second, you could see down, it looks like I've already got this changed, but there's a line there that starts with real, and then it's got A plus BI. So you don't need to change to A plus BI mode to do operations using the I character. When you need to change the mode is if you happen to do something like the square root of -25. Okay, then it needs to be an A plus BI mode, or else it'll give you an error. But other than that, you could be in real mode. I'm going to put mine in real mode, right? And then I'm going to go to that same problem again and enter it exactly like you see it, with all the parentheses in the same places. Clear. Parentheses, -6 minus second I, parentheses, plus 5I, minus 11 plus 13 second I. So just make sure it looks exactly like you see it, and when you hit enter, it'll do the math. And like I said, it's not even an A plus BI mode, and it's letting us do that. So that was actually adding and subtracting was in there. You could also get multiplying, you could get dividing, right? Any of those are operations with complex or imaginary numbers. And also you can get, this is number 12, same package. You can get the powers of I. Right? Now, when we did this, understanding the powers of I was all about understanding where it is your exponent is relative to a multiple of 4. If you remember, all multiple of 4 exponents of I equal 1. Right? All even exponents that are not a multiple of 4 equal -1. Right? If it's 1 more than a multiple of 4, like 4n plus 1, right, then it should be positive I. And if it's 1 less than a multiple of 4, it should be -I. So what we have to look at in these 4 possibilities here is where they fall on the scale in this pattern. So we've got, they're all odds, so it's neither one of these. So we just have to ask, is it 1 more than a multiple of 4 or 1 less than a multiple of 4? Which one of those is 1 more than a multiple of 4? Yeah, this one is 33 is 1 plus 32, and 21 is 1 plus 20. Right, so that would be that. The 47 would be 1 less. That would be -I. And the 15 would be 1 less. That would be -I. So you would use, this is a technology enhanced item. You would, click on these two right there. Now, if you don't remember your powers of all that stuff about multiples of 4 and the exponent, you could just put it in the calculator, right? You could put I to the 47, use the I character on the decimal point, and just put them in that way. And it'll work. Okay, next. So my estimation is if there's 2 imaginary or complex number operations on the test, that we should all get those 2 right. There's no reason not to get all those right. If in doubt, put it in the calculator. Okay, this is number 7. 7 is multiplying radicals. In fact, it's something we would call multiplying binomial radical expressions, because each factor is a binomial and there's a radical involved. How do we normally multiply binomials? You FOIL it, right? So we would FOIL it. Now, if you're going to do this with the math, 6 times 5 is 30. 6 times the square root of 7. And 5 times the square root of 7. And what is the square root of 7 times the square root of 7? 7, right? So that's 37. And then, can you add 6 root 7 plus 5 root 7? What has to be true for you to add or subtract radicals? They have to have the same index and the same radicand. In this case, they're both square roots. That means the index is 2, and the radicand is 7. Okay, since they are the same, they're like radicals, how do you add them? You add the coefficients, right? 6 plus 5 is 11, square root of 7. So the answer is there. Okay, next. Same problem. Okay. You could also, there are no variables involved here. You could also just turn these into decimals, right? Put this in the calculator just like you see it, turn it into a decimal, and then we'll compare it with these 4 and see which one has the same decimal value. Whichever one it is, that's the answer. All right, so let's do that. Clear. Parentheses 6 plus the square root of 7. Make sure when you're inside of a radical, right, that you right arrow to get out of it. Right, parentheses 5 plus. As a decimal, it looks like 66.1. So you could go through all 4 of those. I'm not going to do that because it just takes too much time. But I'm going to do the one that we said was the right answer and show 37 plus 11 square roots of 7 is 66.1. So the answer is that. Okay, now, where this kind of method needs just a little bit of being careful with it is if, for example, you had, simplify the square root of 80, right? And maybe one answer said 2 times the square root of 20, and another one said 4 times the square root of 5. right? The fact is that all three of those have the same decimal answer. So which one of these two would you pick to be the right answer? You would pick this one right here. Why? Because it's more simplified, right? And how do you know it's more simplified? Because it has the smaller number underneath the radical. Okay, so you should have the habit of, if you're doing this kind of a method with radicals, make sure to check all the answers in case two of them have the same value. In this problem here, I could see that all four of them just had square roots of 7, so that was not going to be an issue on this problem. But I would think about that anyways. Okay, that was number 7. Okay, next, number 1. Number 1, I would call adding rational expressions. Remember, rational means like fractions. And what needs to be true before you could add fractions? They need a common denominator, right? And so these don't have a common denominator. I should say that the first step usually for doing this kind of thing is you should factor the denominators. Now, in this problem, there's no factoring to do in either one of those denominators. So we don't really have to do that. But in this kind of problem, you should think about that first. Okay, then how do we make the least common denominator? What goes in it? Well, you write down every factor you see in all the denominators. In this case, there's only 2. The most times that you see them. So like I see n plus 3 as one factor, and I see n minus 4 as another. They're both in their fractions once, so they're there in the LCD once. You know, if you had like a n plus 3 squared in one of them, then you would need n plus 3 squared in the least common denominator. Okay, so once you've got your least common denominator, then let me write this down. 3n divided by n plus 3. Okay, plus 5 over n minus 4. Okay, let me change color. What do I have to multiply the first fraction by so that it has that least common denominator? So I'm going to go n minus 4 times n minus over n minus 4. Right, what about the second fraction? N plus 3 over n plus 3. Okay, now when fractions have the same denominator, how do you add them? You add the numerators, right? So we know that our answer is going to have a denominator of n plus 3 times n minus 4. Okay, now we need to simplify and add the numerators. So this will be 3n squared minus 12n plus 5n plus 15. Okay, and then these two can be combined. Right, that's minus 7n. So the answer is B. Now, this kind of a problem, adding, subtracting, almost anything to do with rational, are some of the most missed questions on the test. And, this was the #1 question on that test that year. So I imagine a lot of students that get to that first one and go, oh my gosh, However, we have strategy for this, right? And the strategy involves storing a value for the variable, and then like we did in the problem before, we're just going to turn it into a decimal. And if we can match the decimal answer with the thing that we were given, then we've got the answer. So the question becomes, what value should I store for the variable? And I know I've told you this before, but so I'm saying if we have one variable, let's store pi for the variable. And the way to do that, like if I want n to equal pi, then in the calculator, and I'm going to do that over here now, clear. First you find the pi character. Where is that? it's over here in the caret key, right? So I go second caret, and then you hit the store, which is in the bottom left, right? STO, and then you find n, which is above the log. Oh, sorry, that was alpha. Alpha log. There we go. Should look like pi, right arrow, n, and then you hit enter. And it spits back the value. Now, if you want, you could use x. If there's only one variable, there's no reason you can't just use x, as long as you keep it straight. Sometimes we have to change to x. Here we don't, but okay. Now, if you have two variables, use pi plus 1 for the second variable, pi plus 2 for the third. Right? Now, a lot of these things I had printed up in a document in the middle of the year because we get asked to remediate all the time. And the funny thing is they gave us this document that came from someplace else. I think it might have been York County, it might have been the Department of Education for the state. And it mostly went through all these same steps, some of which, you know, it almost looked like they copied what I'd done. I don't know if somebody might have shared it. They didn't say to store pi. They said store a unique number above 10. Okay, so 11, 12, 13. I mean, that would probably work. I'm still going to stick with pi. Now, if you look at this problem that we did, right, there was also a lot of fractions involved. So another place where we tend to make a lot of mistakes is we don't put the parentheses around numerators and denominators, and then we make mistakes for that reason. Okay, but we have a fraction format in the calculator. Alpha, y equals 1, right? You absolutely need to know where that is. Alpha, y equals 1. And now when you put it in the numerator and denominator, you don't need parentheses anymore. So I think that one thing probably saves some students a few problems that they might have otherwise gotten wrong. Okay, so let's go back and see how this process works for that same problem that we just did. So I've already stored n equals pi. So now I'm going to put that given expression in the calculator. I've already got my fraction format up, so I'm going to go 3 alpha n, arrow down to the denominator, alpha n plus 3. Right? And then right arrow plus alpha y equals 1, 5 alpha n minus 4. So when I hit enter, it's going to evaluate that expression with n equals pi. And the answer is negative 4.29. So I would write that down up here. And then I would go through these 4 options and see which one has the same decimal value. Now, we already said it was going to be this one here. And again, to save time and because it's really not necessary, I'm just going to show it would have worked to find that one answer right there. So alpha y equals 3n squared minus 7n plus 15. Oh, go to. It wasn't done yet. And then n plus 3 and n plus 4 and minus 4. Right? And when I hit enter, same thing, negative 4.29. So that's the answer. Okay, so if you're hit with that kind of problem as the first one and you're intimidated by it, I mean, this is like a foolproof way of getting it right. No matter what. Okay, this is number 3. Same package. Now, how would we describe this problem? It's factoring the difference of cubes. Okay, so we have formulas for the sum and difference of cubes, and that is what they kind of expect that we're using here. Right, so that'd be, okay, humming. Somebody is. Okay. A to the third plus b to the third equals a plus b times a squared minus ab plus b squared. Right? A to the third minus b to the third. A minus b. A squared plus ab plus b squared. All right. So whether it's a sum or a difference, it always factors as a binomial times a trinomial. So which answers can you eliminate right away? So A and B cannot be the answers no matter what. So you get rid of those two. Okay, now I'm looking at the first factor is the same. In fact, the only thing that's different is whether or not that middle term should have been a 12x or should have been a 6x. Okay, well, let's see. Our x to the third minus 216 was actually x to the third minus 6 to the third. So according to the formula, right, that middle term should have been x times 6. So it should have been this one right there. Now this one does not use the word equivalent, right? But we had some expectation that one of them is just a different form of the same thing. One of these answers would be just another form of the same thing. Most of these kinds of questions for which this storing method would work, you know, it does use the word equivalent. Garrett, right? Stay awake. Okay, so again, we could store this. Store for x. Second pi, store x. Enter. And x to the third minus 216. Negative 184.99. Write it down. And then again, sometimes if you're just like purely going to use this method, you could also combine just a little bit of math. Like you could remember, you know, I don't remember those formulas, but I do remember it's supposed to be a binomial times a trinomial. So I don't need to check these two, right? I only need to check the last two. And so then just check the last two. And I'm not going to go through that, but again, it would be this one right there. Okay, next. Number 4. Right. How would we describe this one? Yeah, it's operations with radicals, right? So this is actually subtracting radical expressions. Now, as we said before, you can only add or subtract radical expressions if they're like radicals. And these clearly are not like radicals, right? But you're supposed to simplify. So if we simplify and they are like radicals, then maybe at the end we'll be able to combine them. So let's try to simplify. The square root of 75x to the third. So the first thing, dealing with the number, you got to say to yourself, is 75 a perfect square? No. Does it have any factors that are perfect squares? The answer is yes. In fact, it would be 25 times 3. Now, if you're not good with that kind of thing, this is a strategy for simplifying radicals without turning them into decimals. Go to y equals. Go to y equals, and on the first line, since this is a square root, you put x squared. On the next line, you put your number, 75, divided by x squared. Right, and then you go to the table of values. And you should go down the first column, right, the y1 column, the blue column, and look for 75. And if you look, it goes 49, 64, 81. Okay, right there it just jumped over 75. Okay, so at that point, you go into the right column, and then you go up until you find the first non-decimal, which is 3. So actually this should be 25 times 3, and the square root of 25 is 5. So, I mean, in the end, it's going to be the first column times the square root of the last column. That's always the way it works. All right, so let's see. So I'm going to split up the 75 into 25 times 3. How about the x to the third? Can I simplify the square root of x to the third? Do they all come out? No. Why do they not all come out? Right? Because there's a little invisible index of 2 right there, and 3 doesn't divide by 2 evenly. Right? So how could I split up the x's so that I can simplify a little bit? Right? We're going to make that x squared times x. Okay? And then we'll take the square root of all of those things. Okay, same thing with the next one, right? 27 is not a perfect square, but it has a factor, 9, that is. And then we got another x to the third, so we'll split that up the same way. X squared times x. So this is 5 times the square root of 3. What's the square root of x squared? X times the square root of x minus 3 times the square root of 3, x times the square root of x. And then we want to combine all the things that are outside the radical and all the things that are inside the radical. So it'll be for both terms. So that'll be 5x times the square root of 3x minus 3x times the square root of 3x. Okay, now we have like radicals, right? They're both square roots of 3x. So how do we combine? Subtract the coefficients. What's 5x minus 3x? 2x times the square root of 3x. Done. That's how you do that one with the math. Now, could you use the store value method? You know, the key here is, if it's got that word equivalent, then yes, you can. Right? It should be true that one of these is the same as what was given for all values of x. So it should be true for one value of x. So the store method works. Okay, I'm not going to go through it all just to save time, but the store method would work. Now, because radicals are involved, I would still recommend like check all 4 answers, make sure there's not like one is a more simplified version of the other. Okay, next, number 5. So this one, I would call this one simplifying a rational expression. Okay, what's the first step we should take? You should factor everything. Ultimately, we're going to want to cancel common factors, but at this point the denominator is factored, but the numerator is not factored. So we're going to do, you know, if there's a first step always is to factor everything. Okay, so how do we factor r squared minus r minus 6? Okay, so what two numbers are those? So plus 2 and minus 3. Now, here's an app that's in these calculators that we're allowed to use on the SOL that I was not really that familiar with until this year. But if you look, right, apps, and if you go to the apps key, which is right there, see it? And then you look at all the choices there. On most of these calculators, it's at number 8. But in any case, you're looking for PLY SMLT2, right? PLY is for polynomial, SMLT is for simultaneous. If you hit that one, the very first option is polynomial root finder. If you hit 1, it's going to bring up a screen that most of the time the order is 2, which means you can solve a quadratic with that thing. And you want that. So your options are along the bottom of the screen, and the way you pick them is by picking the button that's underneath. So if I want to go next, I just hit graph. And then it gives me a chance to enter my quadratic. So in this case, it was r squared minus r minus 6. So I need it to be 1x squared, 1, enter. I need that to be a minus, enter. I need another 1. You see. Enter. I need that to be a minus, and I need that to be a 6. Right? And when I've got everything the way that I want it, then again, solve is right down here, so I hit graph. And it tells you that the zeros of this equation to solve are -2 and 3. So how do I turn the zeros into factors? You go x minus, or in this case, r minus the 0. R minus -2 is r plus 2. R minus 3. So if you need that, that is there to help you. Okay, and then I put that over r minus 2 times r minus 3. One. Next. Right? Okay, then what do you do at that point? You cancel the common factors, so the r minus 3's cancel. And then you can pick out your answer from there, right there. Okay. So could you use the store value method for this? Yes, you could, because it says equivalent. You could definitely store a value, right? The store method works. Okay. Next, number 6. So this is an exercise in converting from radical notation to rational exponent notation. So if you remember, if I have like x to the 2/3 as a rational exponent, as a radical, the 3 that's in the denominator there goes in the index there. The x squared goes either inside the radical, or maybe you could put the x inside and the 2 outside. It would be the same thing. So I'll put the 2 inside. Okay. So we are dealing with this 4th root. So looking at the 4 options there, which are 2 options I could just get rid of because it can't be them? Right. A and C don't have that 4 in the denominator of a rational exponent, so it's not going to be those 2. And so you've got to pick between B and D. And they both have the same x and y with the same exponents. So the only thing that's coming down to is the 4th root of 16 equal to 2 or 4? And the answer is 2. And what do you multiply together? 4 times to get 16. That's 2 times 2 times 2 times 2. So the answer is this. That's doing it with the math. Okay. Now, could I use the store value method? Yeah, it says equivalent. You could do that. How would you find the 4th root of something? Yeah, math 5. So remember where to find that. Math 5. So as long as you got that, the store method would work, equivalent, so store method works. You can see we've done now, that's all, I don't know, 5, 6 problems that this method works on, and they were all different kind of problems. Right? They all had their own math procedures, but this one calculator procedure solves them all, almost in a foolproof method. So, okay. Now, here's one. It's not a multiple choice. So you can't necessarily use the store method to, just find the option which is going to be right. What you can do is solve it and then use the store method just to check to see whether your answer is the same as the one you started with. Because if it's not, then you need to go back and do something else. So if I'm going to do this with the math, the first thing that I need to do is find the third root of 162. Is it a perfect cube? If it's not a perfect cube, how do I simplify it without turning it into a decimal? Because you could see the numbers we're given here, we don't want decimals. Again, use the calculator. Let me go main and 6 and y equals clear. So on the first line, put x to the third, x to the third. Right. On the next line, put 162 divided by x to the third. And then go to the table of values. Now look in the first column. Go down the first column, the y1, until you get to 162, or where it would have been. In this case, it looks like we're jumping from 125 to 216, so we're right over the top of it. Okay, so then I go into the right column, and from there I go up until I find the first non-decimal 6. So actually, I could split this up. This is 27 times 6, and the cube root of 27 is 3. So that's how we're going to split it up. In fact, I'm going to just do it like, okay, it'll be 3 times the cube root of 6. So I'm going to take technology enhanced item. I'm going to take that 3 and I'm going to put it outside. Right, I'm going to take the 6 and I'm going to drag it over and put it here. Okay, how about the cube root of x to the 6th? Cube root of x to the 6th is 2. It's x squared, right? So remember, 6 divided by 3 gives you x squared. How about the cube root of y to the 7th? Can we take them all out? How can I break up the y's so I get the most simplification? Yeah, I need to make that y to the 6th times y. And the cube root of y to the 6th is y squared. The cube root of y, I cannot simplify, so that stays there. So there's the answer. So like I said, one way or the other, however you get to this point, you could check your answer by storing values for x and y. What value would I store for x? And what do I store for y? Pi plus 1. Yeah. Can use store method to check answer. Okay, that was number 8. Okay, here's number 9. Right, another one of these rational exponents to radical notations. Which two answers can I throw out right away because of the denominator of the rational exponent? Right, A and B don't have a 7 there in the index, so it can't be either one of those. And then let me just look at this x to the 3/7, right? If I convert that to a radical, what is the index of the radical? 7, right? What goes inside the radical? X to the 3rd. Can I simplify that? No, because the 3 has to be at least as big as the index, right? The power of x inside got to be at least as big as the index, or else nothing's coming out. And so based on that, which one of these two has to be the answer? It's got to be C. Okay. Now, would the store method have worked? Yes. Store method works. Okay, next. So here's another, not a multiple choice. It's not a multiple choice, so you're not going to be able to just pick from the list or anything like that. But you will be able to check your answer. You know, at the end, you could see whether your answer has the same decimal value as that. If we were going to do this just with the math, remember I have to go 8 times negative 5 is negative 40. Are there factors of negative 40 that add up to negative 18? Yes. Negative 20, positive 2. Right? What do we do with those two numbers? You split up the middle term. 8x squared minus 18xy. Oh, that was wrong. I meant to say 20. Minus 20xy plus 2y minus 5y squared. Then I group the first two terms. I group the last two terms. I factor each set of parentheses. 4x times 2x minus 5y plus y times this is supposed to have x right there. 2x minus 5y. Now, because what's in parentheses is the same, last step, 4x plus y times 2x minus 5y. You know, that's a systematic way to do this and get it right. Another method you could use, and this is a math method really, is just guess and check. I mean, you could always just guess and check. Like I could just say, okay, let's say x plus 5y is the first one, right? Right. Well, if I'm going to multiply the first term in both sets of parentheses and get 8x squared, then the next one has got to be 8x. Got to start with an 8x. And I'm looking at my options here. The only other option would be 8x minus y. Now, that'll give me the right last term. 5y minus times negative y is minus 5y squared. But does it give me the right middle term? And it doesn't, right? That's going to give me 40xy minus 1xy, which is 39xy. So I mean, you could guess. If you did it on the next step, you'd probably try 2x minus 5y, right? And that is actually one of the factors. So you would actually probably, by guessing and checking, it would have taken you like one trial where it didn't work and the next one would. And again, you could use that store value method just to check your answer when you're done. Say what? Yeah. Okay, so here's 13. Remember 13, when you have fractions inside of fractions, that's called complex fractions. Okay. So how do you divide by fractions? You flip and multiply, right? So I would say this is n minus 15 over 9n. And then I'll turn that into a multiplication. 15 minus n. Oh, that was wrong. Getting tired. 3n to the 5th over 15 minus n. And now there's no factoring to do in any of these. So I can go right ahead and start canceling factors. Like this 3 goes into 9 3 times. Right. This n in the denominator is to the first power, and then you've got an n to the 5th power in the numerator. So that cancels with one of those, leaves a 4. And then what about n minus 15 and 15 minus n? Can they cancel? Well, I mean, what's the relationship between the two? They're opposites of each other, right? 3 minus 1 is 2. 1 minus 3 is negative 2. So, in fact, you can cancel them, but then you got to leave a negative 1 behind. Right? So, that's everything that we can do here. So now we've got a negative n to the 4th divided by 3, which is this one right here. Okay, so could we use the store of value method? Yes, you can. What about the fact that this one here has got fractions inside of fractions? You can do that in the calculator, right? If you go alpha y equals 1, and then in the numerator, you do alpha y equals 1 again, you just put a fraction in the numerator. And then you can go down to the denominator and do the same thing. Alpha y equals 1. So there's nothing that stops you from using that method for this. It says equivalent, store value will work. Right? Okay, and I think I'll skip over that one. I think I'm going to delete that slide. Okay, so now we're moving on. Change the subject. Well, just the interesting thing to note, if I go back to the first store of value, just count how many would have solved. That method would have solved. It started with 1, right? So you can count. 1, 2 for number 3, 4, that makes 3, 5, we're up to 4, 6, and now there's 5. Same problem, doesn't work. Okay, now we're up to 6 for number 9, it doesn't work, and 7, and that was like in the first 13 problems. You know, out of the first, more than half of them you're going to get right if you just follow that method. Okay. Systems of equations, right? This says, identify the solutions to the systems of equations. Where do you look for that on the graph? Louder? They're intersection points, right? So here and here. I mean, this was a technology enhanced item. You were just supposed to use your mouse and click, click. That's it. What do you think is the common mistake made with this? That maybe, yeah, you go for the x-intercepts, because when you're solving one equation, that is where you look for the solutions. But for a system, that's not. Right? So, okay, second, what if you're given a system of equations and you have to solve? What were the methods that we have to solve? Okay. Substitution, elimination, and then one more. For graphing. Right? So how does substitution work? What would be the first step? Right. So if it's substitution, right, then you solve one equation for one variable. right? Then what? Right? You substitute into the other equation. Okay. Okay, how about elimination? How does that work? Okay, so we're going to add or subtract these equations to eliminate one of the variables. If necessary, we would have to multiply by something to make that happen. Do we need to multiply these equations to make it happen? I mean, in the end, you've got a y and a y. They're both positive y's. So what will you do to eliminate the variable? Subtract. So you could multiply by -1 so that you could just add. That might be better. So remember, elimination is add or subtract to eliminate a variable. Okay, so if I was going to do that here, like I say, it's already set up. I would probably subtract the second equation minus the first so that I keep a positive x squared. So that is going to give me x squared minus x minus 12 equals 0. Right. Now notice that this thing, it didn't ask for the solutions, the points themselves. It asked for the x values only of those points. And now we're solving for x, so we should get them directly. Right, so how do I solve that? I mean, the easiest thing to do is factor, right? X minus 4 times x plus 3. So the answers are -3, +4. Right, if you don't remember how to do that, I mean, you're not good at factoring, remember the app. You know, the app will get that for you. Okay, how does the graphing work? Gabrielle, say again. Okay, so you have to solve for y, right? Solve for y first. So that first one is going to become y equals -x minus 10. Right, the second one is going to be y equals -x squared plus 2. Okay, so then what do I do with that? Okay, go to y equals, clear, clear. And on the first line, -x minus 10 and -x squared plus 2. And then I look at the graph. And I see one intersection point, and I can tell there's another that's probably just off the screen on the bottom right. Okay, how do I find that first intersection point? What are the steps? Second, trace 5. Then what? Enter, 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 right? So notice that it says it's asking me first curve, and it's giving me a point. The cursor is blinking on one of the lines, and it's giving me the point x is 0, y is -10. So it's already on a curve, so I hit enter, enter, enter. And it says -3, -7. So those are the coordinates of that point. Now remember, they didn't ask for that. They asked for the x values of both points. But they've got as option A, -3, -7. So you might look at that right away and think, there I go. That's it, -3, -7, and you'd be wrong. Right? So be careful of the way they worded the problem. Okay, now how could I adjust the calculator so I can find the second intersection point? Zoom out, right? So I'm going to go zoom, 3, enter. And now I can see them both. Okay, now if I do the same set of steps, second trace 5, it's going to keep going to that same first point. How do I make it go to the other point? Cursor over so you're closer to it, right? So second trace 5. I'm going to right arrow so that it's closer to the other point. Enter, enter, enter. And it says 4. So there's my -3 and 4. So those were the only 2 systems questions on that test. One of them was just a graph. We should all get that one right. This one may be a little more difficult. But the reason I like to teach that one now is because then we're going to get into solving equations. And solving the equations by turning them into systems is a really good way to solve every kind of equation. Okay. This is number 14. So this, I would call this a radical equation. How do you solve radical equations? What's the first step? Isolate. Right? Isolate the radical. So in this case, that means subtract 4. Okay, once I've done that, then what do? Right? Then you undo the radical. In this case, it was a square root, so we square both sides. So that is 8x minus 1 equals 16. 8x equals 17. X equals 17 over 8. Boom. And you're probably well seasoned in back substitution if you have to, right? In a multiple choice problem like that, you could always just like take the first 67 over 8, plug it in, see whether it works. Right? Now, if you're going to use that method, it might even help then to use the store value. You could store 67 over 8, stow, x, enter, and then enter that expression in there. Be a lot less like having to fidget around with square roots and fractions and things like that. And then just keep going until you find the one that works. Right? The other thing you could do is you could turn this into a system. On y1, put the left-hand side. On y2, put the right-hand side. 8. So let's see how that works. Second square root. Make sure to right arrow to get out of that. Plus 4. And then we put in 8. So that looks right. Then I hit the graph. Okay, let me zoom 6 to get it back to normal. There's the first, there's the second. Do we see an intersection point? Yes, we do. So we're going to go second trace 5. Notice this time y equals is blank. That means actually your cursor is not on anything yet. So you could hit enter, but it's just going to stay on first curve, first curve, first curve until you right arrow to get it onto the graph. And now you hit enter, enter, enter. And the answer is 2.125. And if you turn this one into a decimal, you'll see that's 2.125. So that was a square root. Yeah.
If you're doing that and it's like not on the graph, like the cursor's on the graph, and you press enter, will it have an error or will it understand that?
If it's not on the graph, it just won't go forward. Like I pressed many times there. It just keeps saying first curve, first curve, first curve. It does not even give you an error. It just, you sit there and go, why is this thing not working? Because it's not on the graph. Okay? So here's a cube root, number 17. It's already isolated. How do I undo it? How do you undo a cube root? Cube it and cube it. Right, so that gives us 1/4 x plus 3 equals 8. Solve for x. 1/4 x equals 5. Multiply times 4. X equals 20. So that's there. Whoops. So again, you could back substitute, or you could solve as a system. So you have options here. Okay, so we had a square root, we had a cubed root. Let me just say back substitute, the back substitution, or solve as system. Works. Okay, next. Number 21. Now we got a fourth root. These are all in the same test. And they're really not particularly hard problems, mathematically. They're pretty clean, nothing tricky in them. Right, this one you would have to isolate. How do I undo a fourth root? You raise to the fourth power. So now we've got w minus 4 equals 3 to the fourth, which is 81. So w equals 85. Bingo. Next. Now just say back substitution and store and system store. Back substitution, and solve as system. Works. Next. Okay, now we've got a rational equation. Remember, there's two kinds of rational equations. You got the kind where it's one fraction equals another, like this, and then you got the kind where it's not one fraction equals another. Right? What do you do if it's one fraction equals another? Cross multiply, right? You need to get that n out of the denominator, so cross multiply. 4n minus 37 times n equals 3 times 10, which is 30. So 4n squared minus 37n minus 30 equals 0. Okay, so cross multiply and simplify. And then in this case it's a quadratic, so solve it like a quadratic. Right? What are the methods for solving? Okay, you could factor. Is it factorable? Are there factors of negative 120 that add up to negative 37? Negative 40 and positive 3? That would have worked. What else? What if you don't remember how to factor? You could use the quadratic formula, right? That's given to you. What else? You can use the app. Right? That's a perfect kind of thing to use that app for. Right? Go to the calculator. Apps. 8. 1. Next. Right? So 4. Enter. Minus. Enter. 37. Enter. Need another minus. Enter. And 30. Enter. And then I hit solve. And it looks like negative 3/4 and 10. So there's your negative 3/4. And I did that with the app. I mean, tell you the truth, at this point, I don't know why anybody would ever use the quadratic formula again. Unless it's imaginary solutions. I mean, that's the only reason you would. But, okay. And let me delete that. Got an absolute value equation. What's the first step? This is number 24. Isolate, right? It's always isolate. Right. In this case, that'll be absolute value of 2x minus 7 equals 8. And then what do you do with an absolute value equation? 2x minus 7 equals 8. 2x minus 7 equals negative 8. Solve them both. 2x equals 15. X equals 15 halves. 2x equals negative 1. X equals negative 1 half. And there's your answer. Okay, could we use one of our strategies to get this one? Could you back substitute? Sure, it's multiple choice, just plug them in one at a time until you find the one that works. Could you solve it as a system? Okay, if you're going to solve as a system, where do you find absolute value in the calculator? Remember, either math num 1 or alpha window 1. Either one of those. You need to know where that is. Okay. So I just say back substitution. Okay, now here's another rational equation, number 25, and it's not multiple choice. So how do we solve this with the math? You can't cross multiply. Remember, you multiply by the least common denominator. What is the least common denominator here? It's just x, right? There's a fairly simple multiply by x. So when I multiply the first term, the x's cancel and I get 1 minus x. Right? I multiply the 2, I'm going to get plus 2x. And then I multiply 7 over x and I get 7. So that is a fairly simple equation to solve. So that was a 6. Now, you can't back substitute in a problem like this, but could you solve it as a system? And the answer is yes, you can, very easily. Although it's an interesting one to watch how it works. 6. So on y equals, clear. So first I do alpha y equals 1, and I put in my 1 minus x over x plus 2. And then I put in 7 over x. And then I graph, zoom 6. So, what you could see from the graph is that there's clearly an asymptote at x equals 0 because you got x's in the denominator. So when I try to go second trace 5, I'm on x equals 0, so there's no y value, right? So I'm going to have to cursor one way or the other to get onto a graph. Now, if I cursor over to the left, which I know the answer is not there, watch what happens. Enter, enter, enter. And it just says no sign change. It doesn't find the solution because it's on the wrong side of the asymptote, right? So I quit. Now if I do the same thing again, second trace 5, and now I'll right arrow to get me over onto the other side. Okay, now it's on the other side. Enter, enter, enter. And it jumps to the 6. So there's your 6. Okay, so that is, to me, that's just a great method. I mean, it'll solve any equation for you, any equation, just as long as you know how to do these steps. Okay, so the homework is coming from a different package, which is why your county provided review package. That's a lot of problems. You probably won't get to all of them before we meet next. But if you get to some and have questions, then we can go over them in class. I think there will be time to work on them in class also, because that next class I'm not trying to cover near as much. Okay, so let me hand those out to you now.